So, now we want to continue our discussion on two level systems, but what we would like to do is, well, we are continuing the discussion. So, there is no but anyway. We will go back and write down the expression that we had arrived at the end of the last module, and that is A by B equal to 8 pi h nu 1 2 divided by C whole cube. What does nu 1 2 stand for once again? This frequency nu 1 2, what does it denote? It denotes the energy gap. So, from this expression, what can we say about the relative propensity? I do not want to use the term probability right now, relative propensity of spontaneous emission and your stimulated emission. First thing that we have to recognize is that A is never equal to 0 if B is not 0. Sounds very simple, because A is some constant multiplied by B, right, and that constant is not 0. So, if B is not 0, then A cannot be 0, and if B is 0, then what does it mean? That means even absorption will not take place, right. We just proved that B is the same no matter whether it is absorption or stimulated emission. So, that means if B is 0, the transition is forbidden. Okay. In our spectroscopy course, we have worked out the relationship between Einstein's B coefficient and the square of transition moment integral. Okay. So, that is equal to 0. So, transition is not even there. If transition is not there, what are we talking about? So, in all this discussion, we talk about situations where at least B is not equal to 0. If B is equal to 0, then again we can go home. Okay. So, that is the first thing. Sounds very simple, but actually this is what vindicates Einstein treatment. It is important, and this is something that is going to come handy in our discussion towards the end of this module. A is never equal to 0 if B is not 0, right. Seemingly simple, straightforward, might seem obvious, but extremely important, profound. Second thing is, this is A by B ratio. When is A by B ratio more? When is A by B ratio less? On the right hand side, well, 8 is a number, pi is a number, h is a constant, C is a constant. Nu 1 2 is the only thing that you have any control on. So, if nu 1 2 is large, then A by B ratio is large. That means spontaneous emission takes preference over stimulated emission. So, now see, you remember when you want to make a laser, you want stimulated emission to happen, not spontaneous emission. So, if energy gap is too large, then spontaneous emission is favorable. So, that is not a happy situation for making a laser. That is important to understand. So, smaller the energy gap, better it is if you are talking about making a laser, and that is why the first laser that was ever made was actually a maser, not measure, M-A-S-E-R. What is maser? Instead of light, it is microwave, that is all, microwave. First laser that was made was in microwave domain, and that is where nonlinear optics become very important, because in most of our applications, as we have discussed already, you want blue laser, you want ultraviolet laser, you cannot make them. So, your only hope is to somehow make a laser in infrared and keep on adding those photons, performing second harmonic generation, third harmonic generation, fourth harmonic generation, some frequency generation, and produce the light, of frequency you require. Okay. This is important to understand. Smaller the energy gap, better chance it has for your spontaneous emission. Okay. And to establish this point, I want to do some calculation, and as you know, in calculations I often go wrong. So, you better be careful and do the calculation yourself. Now, before starting, since I already goofed once on the speed of light, I want to eliminate speed of light, and to do that what we will use is lambda nu equal to c, we know that. So, nu by c is equal to lambda, right. So, we can substitute and write this in terms of lambda. In fact, I will go one step forward and write 1 by nu bar, for the simple reason that I remember the wave number of microwave, I do not remember the wavelength. You can do it in whichever way you like, but the point is you can use any one of these. So, you can write A by B in terms of frequency or wavelength or wave number or whatever, energy, anything. See, we are trying to make a laser, that S is for stimulated emission. So, if you want to make a laser, then we have to promote stimulated emission and not spontaneous emission. So, it is better to work in smaller energy gap. If I have said spontaneous, I have made a mistake. Are you clear now? Okay, sorry for confusing. Now, let us write this here. So, what I get is A by B is equal to 8 pi h divided by nu bar cube, is that right? Right? So, if I write A by B for some nu bar 1. So, I will write for nu bar equal to, or maybe I will write it in terms of B by A, because the thing is we want to promote B, we want to promote stimulated emission, why keep it in the denominator, better keep it in the numerator. So, we write something like this, B by A is equal to nu bar cube divided by 8 pi h, and even if I missed out some constant in the process, it does not matter. So, let us see what will be the B by A ratio for nu bar equal to, say, I am making a mistake here, am I not? I am surely making a mistake here, is not it? This cannot be, because nu and nu bar would be in the same place. So, let us see where I have gone wrong. Lambda nu equal to c. So, nu by c equal to lambda, and this equal to nu bar cube. So, why have I written it here? This should have come here. Okay. So, in fact, B by A is equal to 8 pi h divided by nu bar cube. Are we clear? I made a mistake here. So, see, I will just go back once. A by B equal to 8 pi h multiplied by nu 1 2 by c whole cube. So, now then I said I do not want lambda, I do not want nu, I want nu bar. So, I said lambda nu equal to c, therefore, nu by c, which is a quantity here, that is equal to 1 by lambda, which is equal to nu bar. All right. So, as I told you already, please be careful and correct me wherever I go wrong, otherwise we will learn things that are reciprocal of the correct picture. Okay. So, B by A is equal to 8 pi h divided by nu bar cube. So, B by A for nu bar equal to say 200 centimeter inverse divided by B by A for nu bar equal to 20,000 centimeter inverse. B by A equal to everything is in the denominator. Yes, man, this is a mess, 8 pi h. So, that is right. So, because here it is 8 pi h nu bar cubed, but well, it does not matter, because I am going to take ratio of ratios. Okay. What is this going to be? 200 centimeter inverse, what is it? Is it microwave, is it IR, is it terahertz? Yeah. What is 200 centimeter inverse? What kind of light is it? Definitely not visible. Is 200 centimeter inverse. 20,000 centimeter inverse, what is? Yeah. blue or UV, and this is well something that is not exactly microwave, it is still IR. Okay. So, let us take the, now I think the answer is very clear, right. I will put cube and here I write 200, here I write 20,000. What is the answer? 10 to the power 6, right. So, if you want to make a laser whose wave number is 200 centimeter inverse, and if you want to make a laser whose wave number is 20,000 centimeter inverse, which one will be easier? Definitely the 200 centimeter inverse one, because the B by A ratio there is 10 to the power 6 times that of the B by A ratio for 20,000 centimeter inverse. Okay. If you just want to work out the value of A, value of B, it might be a little confusing. So, B by A ratio is something that allows us to understand what exactly is the situation, right. Are we clear? So, the take home message here is, first of all, A is never equal to 0. Second one is, for laser, smaller energy gap is easier. So, this discussion of two level system has actually given us some very important information. What we learned in the last module is, we learned how to get a relationship between A and B, and what we have done so far in this module is that we have seen what is the B by A ratio for different kinds of energy gaps. So, now let us ask the question, what is the finally I want to make a laser, right. So, I want stimulated emission. As you said, as you saw, when light comes in and is impinged two level system, then you can have either upward transition or downward transition. So, if you want a laser, what you want is more photons should come out than what is going in, otherwise how will you have light amplification, right. So, in order to have net stimulated emission, the rate of downward transition must be greater than the rate of upward transition. I am not writing 1 2 anymore, rate of maybe here I should write. Okay. Left hand side is rate of downward transition N2, right hand side is rate of upward transition because it has N1, and we have already established that B's are the same, energy density is the same anyway. So, finally, what it boils down to is N2 has to be greater than N1, and since we are talking about a two level system, we can write N total is equal to N1 plus N2, where N total is the total number of molecules that are there. So, molecules can either be in state 1 or in state 2. So, when you add up the populations of molecules in state 1 and molecules in state 2, you should get N total. So, another way of writing N2 should be greater than N1 is N2 should be greater than half of N total, right. And if I put it in words, then what we will say is that a population inversion is an essential condition so that we get more light coming out than going in. So, population inversion is an essential condition without which you cannot get stimulated emission, and therefore, you cannot get laser. So, now the question is it possible to get population inversion in a two level system? That is what we will prove. I think most of us know the answer that it is not possible, but we will go ahead and prove it. Now, what I will do is I will write the rate equation. What is this term? Rate of which process? B rho 1 2 of nu into N1. It is induced absorption. Next term I will write is B rho 1 2 of nu N2. What is this? Stimulated emission. Okay. Does it populate or depopulate energy level 2? Depopulates. So, what will be the sign, plus or minus? The first one populates N2, so sign will be plus. Second one depopulates N2, so sign will be minus. What is the third term? Spontaneous emission, and it will also have minus because it depopulates, depletes energy level 2, minus A N2. Alright. Now, here of course, there are well, two things to understand. Is dN to dt equal to 0? Only at steady state. But if you start, so if you have a situation where initially you have nothing, then light is switched on, then until saturation is reached, the N1, N2 values will change. N1 will keep decreasing, N2 will keep increasing. Okay. Now, it remains to be seen, saturation of value of N2 has to be there, because you are not producing molecules, right. So, best case scenario is, if at all possible, all molecules will go to N2 state. I am not saying it is possible, but it is, I am not saying it happens, but that would be the best case scenario, right. Initially, when you start, everything is at N1, no N2, and then after some time, all molecules are in the higher energy level. That is the best kind of population inversion you could have. Of course, as we will see, that is not achievable. As you have said already, even population inversion is not possible. I mean, dN2 is never half of n, but then the point I am trying to make is that it is dN2 dt is not 0 until that steady state is achieved. And right now, we are talking about the non steady state situation. Okay. Now, here of course, N2 changes with time, N1 also changes with time. N1 decreases from the initial value and N2 increases from 0. So, two variables, one equation will be difficult, but then we know already that I can write like this: N1 is equal to N total minus N2. In this equation, which are the time dependent quantities? Is N total time dependent? No, it is a constant. N1 and N2 are time dependent, right? They are variables, but then of course, they are correlated to each other. So, what I can do very conveniently is that I can write, I can replace N1 by N total minus N2, that way it becomes an equation in N2, and we are in a comfortable situation, we can try to solve it. So, let us write quickly. Rest of it is quite simple algebra and very little calculus. dN to dt equal to B rho 1 2 of nu N total minus N2 minus B rho 1 2 of nu N2 minus A into N2. Okay. To formulate it makes sense to collect all the terms in N2. In fact, out of all the terms that you get, only one does not have N2, isn't it? The first one. So, that is the only term, B rho 1 2 of nu multiplied by N total. Is there a constant with respect to time? This term, that is a constant, right? And all the other terms are variable. Not only that, the only variable there is N2 and everything has minus in front. So, I can happily take this minus out and I will take N2 out at the end. So, what do I get? I will write A first and then see this one is B into rho into N2 with a minus sign. This one is also B into rho into N2 with a minus sign. So, it will be A plus 2B rho 1 2 of nu into N2, right. If you are good in calculus, you can actually write the solution right away. But since I am not good anymore, I will do it step by step. Let me say y equal to right hand side, b rho 1 2 of nu in total minus a plus 2b rho 1 2 of nu into N2. So, what is then dy dt? First term is constant. So, that goes. Second term I can write like this, minus a plus 2b rho 1 2 of nu dN2 dt, right. So, instead of this dN2 dt, I can write dy dt divided by minus a plus 2b rho 1 to nu, and then on the right hand side I can write y. Is that okay? Therefore, I can write like this, dy dt is equal to minus a plus 2b rho 1 2 nu into y. This is dN2 dt equation. This one, I have set this whole thing to be y. Is that right? Now, it is not very difficult anymore, I hope, and I can write something like this, dy by y, and everybody knows what the integral of dy by y is equal to minus a plus 2b rho 1 2 of nu dt. And what do? I integrate, right. Only one trick, I mean not trick, one pitfall is there. When I integrate, I am going to do a definite integration. I am going to integrate from 0 to time t. So, right hand side is quite simple. Left hand side is also quite simple, it is going to be ln y, but we cannot forget what y is. Upper limit is y, I will just write y for the upper limit. If you want, you can write y dash, it does not matter, then you have to write t dash here. What is the lower limit? What is the value of y when t equal to 0? Go back to the definition of y. At t equal to 0, the second term is 0, because N2 is 0, right. There is no molecule in the second level, that is what we are working with, even though there is a little bit of a problem with that, but we can live with it for now. We are talking about y. So, my question is, what is the value of y at t equal to 0? Second term will be equal to 0. So, y will be equal to b into rho 1 2 of nu multiplied by n total, right, that is a constant. So, that is the limit is important, b rho 1 2 of nu n total. Are you okay? Rest is simple. Now, just write the result. Left hand side will be ln y, I will still keep it at y, but then we will change later on, divided by b rho 1 2 of nu n total is equal to minus a plus 2b rho 1 2 of nu t. See if you are convinced with this. Next step is very simple, raise both sides to e, find the antilog. So, right hand side will be e to the power minus a plus 2b rho 1 2 into t. Left hand side numerator will replace y by b into rho 1 2 into n total minus a plus 2b rho 1 2 into n2. Yes, but not yet, because right now left hand side is in ln, right. So, when I take anti-log, then left hand side ln will vanish, right hand side will be raised to the power of e, right. So, I have not done that yet, I am going to do now. Are we okay with this? Okay. So, let me keep it in such a way that you can still see it. That is a solution to our problem. Of course, the thing that you cannot see still is what is y. We will need that also. So, what I can write is, now I will try and expand. You have understood what I am doing? Raising both sides, right, and taking anti-log, right, and let us not forget what is y. So, what will the left hand side be? ln will vanish. So, instead of y I am writing this expression, that is all. It is a little long, not difficult. B into rho 1 2 of nu n total minus A plus 2b rho 1 2 of nu into n2 divided by b rho 1 2 of nu n total. Even before I write the right hand side, do you see the beauty of this expression? If I expand, the first term is 1, second term has n2 by n total. n2 by n total is what we are looking for, right. So, we are getting there, is equal to e to the power minus a plus 2b rho 1 2 of nu t. Okay. So, now simplify a little bit. So, left hand side you can see, right, it is 1 minus this thing divided by this. So, can I jump a step? I will just take the second term to right hand side. So, that minus sign will go, and I will take 1 to the other side. Are we okay with that? So, then what I have is a plus 2b rho 1 to nu n2 divided by b rho 1 to nu n total. I have taken this to the right hand side. So, on the left hand side I have 1, and I am taking this actually to the left hand side. So, minus e to the power minus a plus 2b rho 1 2 of nu t. Okay. Now, climax is there, n2 by n total is equal to b rho 1 2 nu divided by a plus 2b rho 1 2 nu multiplied by 1 minus e to the power minus a plus 2b rho 1 2 of nu t. Okay. This is the expression for n2 by n total. My job now is to see, is it ever possible for this ratio to be more than half? Okay. Because if that happens, then population inversion is going to happen. Let us see. Let me plot. I think we chemists understand pictures better than numbers. So, let me plot n2 versus time. As we have discussed already, n2 at time t equal to 0 is 0. Okay. What is n2 at time t equal to infinity? This is a monotonic function, right. At time t equal to infinity, what will happen? This will become 0, the exponential term, right, because it is e to the power minus, right. So, take it in the denominator, that will denominator will become a large number. So, it is going to be 0 and then you are left with 1. So, what we get is that we get a monotonic increase like this to saturation. And what is the saturation value? I can write N2 at time t tending to infinity. What will that be? Well, actually N total should be here then. What will that be? What will N2 by N total be? So, this thing is gone, right. So, N2 by N total, best possible value, maximum value at time t equal to infinity, turns out to be B into rho divided by A plus 2 into B into rho. Okay. So, this is actually the best possible value, saturation value t tends to infinity. Of course, when I say infinity, I do not mean real infinity, it can be really small time, but it is saturation value, that is all. Now, see, now remember we said that A being non-zero is going to be useful, here it is useful. See, if A would be equal to 0, then the best, then it would have been half, right. So, population not exactly inversion, but at least population equalization would have happened. But what you have said is that A is never 0, if B is not equal to 0, if B is not equal to 0. That means that this ratio N2 at time t tends to infinity by N total will always be less than half. Have I been able to make the point? Yeah. So, this is why population inversion can never be achieved in a two-state system. The best possible value is still a little less than half, okay? And half is not good enough actually. Little more than half is what is required for population inversion, that is never achieved, even half is not achieved. So, this two-level system which has given us all the important quantities that are relevant to lasers, unfortunately cannot give us an actual laser. If we want to make a laser, the stimulated emission will be there, we have to add at least 1 or 2 more levels. So, that is what we will study in the next module. We will talk about 3-level and 4-level system, and then maybe I think we will have time for it. We will do a little bit of calculation on our own laser to get an idea of some of the numbers associated with it.